Hi everyone, for today I'm going to teach you another probability lesson and it's about independent events multiplication rule number 1 is the subtopic. Let's define first what do you mean by independent events. So two events are said to be independent if the fact that the event A occurs does not affect the probability that event B occurs. Generally speaking, independent events are not affected by previous events. On the other hand, when we say dependent events, it's the opposite. Two events are said to be independent if the fact that event A occurs affect the probability that event B occurs. So generally, dependent events are affected by previous events. Let me give you some illustration, or this diagram will help us identify if a certain problem or situation is dependent or not. So is it possible for the events to happen in any order? If the answer is no, then that means it's automatically dependent. If the answer is yes, then you need to ask another question. Does one event in any way affect the outcome of the other? If the answer is no, then it's independent. If the answer is yes, then it is dependent. Now let me give you 4 illustrations. Let's consider this one. Tossing a coin and selecting a card from a deck. So you toss a coin, there are two probabilities. Let's say that event already happened. Will that affect the probability of, let's say, selecting a card from a deck of 52 cards? Absolutely not. It's not going to affect. So that means it's independent event. Let's go to real life example. Driving on ice and having an accident. Is there a correlation between those two? Is that ice on the roads going to affect your driving? Is there a possibility that there will be an accident? Yep, there is a probability. That's the key word there. There's a probability that you're going to have an accident, so that means it's a dependent situation. Dependent event. All right, let's go to the next one. Picking a card from a deck twice without replacement. So let's say you have 52 cards. You picked one. Okay. Now what's the remaining cards is just 51, so that means the probability of getting another card from that 51 is going to be affected because your denominator is 51. Originally it's 52, so since the denominators are different, then this is an example of dependent event because the first event is going to affect the probability of the second event. On the other hand, here, pick a card from a deck twice, but this time with replacement. So you picked one card from 52. Let's say you were able to get that card and you replace that by the same card. You pick another card, regardless of whatever card that is. The probability of picking that card is still this. I mean, it's not the probability of that is not gonna be affected by the previous event because the denominator is still 52. Originally it's 52 and again it's still 52. So meaning this is an example of an independent event. All right, let me give you some examples. Or by the way, let me just give you the multiplication rule number 1. So if there's two events, if there are two events, the probability of those two events is probability of event A times the probability of event B. If there's more than two, then you just multiply the probability of each event. Let's have this example. A coin is tossed and a die is rolled. Find the probability of getting a tail on the coin and a 5 on the die. So a tail, that's the desired outcome over the possible outcomes, which is the total number of outcomes, which is 2. Multiply that by, that's 1. There's only 1 5 on a die, and then the number of possible outcomes will be 6. Multiply those two, the answer will be 1 over 12. That's the probability, or less than 10%. All right. An urn contains 2 red balls, 3 green balls, and 5 blue balls. Let's stop there for a while. In total, we have how many balls? We have 10 balls. A ball is selected at random and its color is noted. Then it is replaced. Now it is implied here that it will be replaced by the same color. Let's say you picked one red ball and then it will be replaced by another red ball. So the key word here is the word replaced. And another ball is selected and its color is noted. Find the probability of each of this. So we will pick how many? We will pick 2. So a ball is selected at random and it's noted and then replace, and another ball is selected. So you will pick twice. All right. So on the first pick, what's the probability of letter A? The first question is selecting 2 balls. So the first probability of selecting a blue ball is 5/10. Why is it 5? Because there are 5 blue balls, and 10 is the total number of balls we have here. That ball that we don't know is replaced by the same ball. So the probability of the second is still 5/10, which means it's 1/2. This is 1/2. This is 1/2. That is 1/4. So that is around 25%, or exactly 25%. 1 times 1 is 1, 2 times 2 is 4. Selecting a blue ball and a red ball. So blue ball, how many blue balls do we have? So that's 5/10. The denominator does not change for the second trial. And we want to have a red ball, so it's 2. Okay, equals. So this is 1/5. This is 1/2. So 1 times 1 is 1. 2 times 5 is equal to 10. So that's 10%. All right. Let's go to the last one for this particular example. Selecting a green ball and then a blue ball. Green ball, how many green balls do we have? We have 3/10. Multiply that by a blue ball, which is 5/10. So 5/10, that's 1/2. 3 times 1 is 3. 10 times 2 is equal to 20. Right? So that's 3/20. Or if you want to convert that into decimal, you can do that. Just divide those two and then multiply it by 100. All right, let me give you another example. So this time we have 3 events. Now a die is tossed 3 times. Find the probability of getting 3 5s. Okay, so on the first try, what's the probability of getting a 5? That's right, it's 1/6. On the second try, what's the probability of getting a 5? It's 1/6. On the third try, what's the probability of getting another 5? So 1/6. So if you multiply those 3, that is 6 times 6 times 6. That is equal to 216. So 1/6 times 1/6 times 1/6 is equal to 1/216. Oh yeah. Let's go with another example. It is known that 70% of students at a large college favor building a new fitness center. If 2 students are selected at random, find the probability that all of them favor the building of a new fitness center. So student number 1 and student number 2. Student number 1, the chances that that student favors the building is 70%, or 0.70, right? The chances of, the probability of the second is still the same, so that's 0.70. So just multiply those two. So 0.7 times 0.7, the answer is 0.49. That's close to 50%, right? Let's go to another example. What is the probability of guessing and getting all the correct answers in a 5-item classwork if each item has 4 choices? So, oh, wait. Let me just give you an illustration here. So item number 1, item number 2, item number 3, item number 4, item number 5. Okay? And then in each problem, there are 4 choices. So let's say A, B, C, D, D, A, B, C, D, A, B, C, D, A, B. Oh, what happened? A, B, C, D, A, B, C, and D. All right. So let's say you're just going to guess. What's the probability of getting a correct answer for number 1? It's 1/4. For number 2 is 1/4. For number 3 is 1/4. For number 4 is 1/4. For number 5 is 1/4. So that's 1/4 times 1/4 times 1/4 times 1/4 times 1/4. Or we can actually write that as 1/4 raised to 5, because we will multiply 1/4 by itself 5 times. Yep. So 4 raised to 5 equals 1024. So this is 1 over 1024. So the probability of getting a correct answer or 100% in all of the questions if you answer a 5-item classwork is actually less than 1%. That is if you will guess. All right. Let's go to the last example here. If two people are selected at random, find the probability that both were born in August. So person number 1, let's say A, person number 2 is B. So August is the desired outcome. There's only one August in how many months? 12, that is correct. So the first is not going to affect the probability of the second one. It's still 1 over 12. Multiply those two, that is 1 over 12 times 12, I believe is 144. So that is the answer. And if you try to compute the percentage of that, if not mistaken, that is also less than 1%. Yep. So there you go. That's how you answer problems involving independent events. The subtopic here is the multiplication rule number 1. All right. Thank you for watching, and I hope you learned something. Bye bye.